Welcome back. We're going to be looking into factoring, but this time we're going to have our a value in front of x squared be something other than 1. So let's look at this example here. We're going to be factoring this trinomial, but we have a 3 in front of a instead of just a 1. So instead of just having x squared, we have 3x squared. So I'm going to use that cross multiplication / xbox method as I have in the past. So I'm going to ask myself, well, what times what gives me 3x squared? Well, 3 is prime, so I only have one choice. I can say 3x and x. That'll give me 3x squared. Then I'm going to look at 8, and I'm going to say, okay, well, what times what gives me 8? Now, normally I could say, well, 4 times 2, 8 times 1, but you see the negative sign here? That's a bad color to use. The negative sign here? That tells me that because it's a negative, that means the signs here for the 8, the two numbers, also have to be negative. They both have to be. So that's going to help guide me. So I'm going to try, let's say, negative 4 and negative 2. Okay? So I'm going to cross multiply. So I got 3 times negative 2, which is negative 6x, and then x times negative 4, which is going to give me negative 4x. When I add those together, well, it equals negative 10x. Exactly what I want in here. If I didn't get it the first time, I would rearrange the numbers, try different factors. But the more you get it, the more you do it, the easier it comes along. And you start noticing those patterns more quickly. It's kind of like playing an instrument or playing a sport. You get better the more you do it. So I have my factors laid out for me. It's 3x minus 4 and x minus 2. So I'll just write that out. It's going to be 3x minus 4 and x minus 2. And it's factored. And if I want to solve it, it'd be set equal to 0, and we could go from there. But factoring is good enough for this. Alright, so let's try another one. So I'm going to factor 6x squared plus x minus 15. Okay, so in the case this, I'm going to ask myself, well, what times what is going to give me 6x squared? I could go with 2x and 3x, or 6x and x. I'm just going to try 2x and 3x. I don't know if that's going to work. Maybe it will, maybe it won't. And the negative 15. Okay, so this tells me here that that's a negative, tells me that the numbers have to be opposite signs. One has to be positive, one has to be negative. This tells me the, quote, bigger number has to be positive. Okay, so that's usually going to be the case. Okay, but I know for sure that negative is going to tell me that the signs have to be opposite. So let's see, I could say like a negative 5 and a positive 3. Okay, so let's try that. I'll say positive 3 and negative 5, and I'll cross multiply. So that's going to give me negative 10x plus, and then that's going to give me 9x. Okay, well, that's going to give, when I add those together, that's just going to give me negative 1x. I want a positive 1x. Ooh, I'm really close. So probably all I have to do is change my signs. So it looks like I got, pretty lucky. Not really. I've done this for a while and I'm kind of used to it, as you will. And look, so I'll say 2x times 5 gives me positive 10x, and this is going to be negative 9x. And look, when I add those together, that's going to be positive 1x. Exactly what I want there. So I got my factors. Okay, pretty quick, pretty painless. Right there. So I would write it out. My answer would be 2x minus 3 and 3x plus 5. And I'm done. Pretty sweet, huh? Yes, it is. I don't care what you think. I think it's sweet. All right. Recall the special factoring patterns. We're going to mess with these again. Difference of squares, perfect square trinomials, this is the same, but now we're going to do it with values of a that are greater than 1. So I'm going to look at this first one and say, oh, I got two terms here. Maybe this might be a difference of squares. I mean, I see right away I got a minus sign here. That's a good thing. Is the first term a perfect square? Well, sure, that's just 9x squared. And is this a perfect square? Sure, that's 5 squared. That gives me 25. So all I have to do is say, hey, well, that's going to be 9x plus 5 times 9x minus 5. Well, pow! That's it. You're done. If you recognize those patterns, life is going to be easy, pretty smooth. And it doesn't matter which one you put first, the minus or the plus. It works out to be the same. Okay, example 4. Okay, so I would say, all right, I got a trinomial. And you should kind of get used to doing this, like, to begin with. Just kind of look at it and say, well, is this a perfect square? Is this a perfect square? And is this 2 times a times b? But I want you to also be looking at the signs. Okay, so make sure this second sign always has to be plus. If it's minus, it's not a special product. So this is a minus plus, which tells me it's going to probably be a minus sign in both binomials, if it is in fact a special product. So the first term, okay, is that a perfect square? Sure is. That's just 3r squared. And then, is this a perfect square? Sure, that's just 11 squared. Now you can do this mentally as well, but I'm just writing it out for the sake of seeing this. Then this middle term here, it needs to be 2 times a times b. Okay, so it doesn't matter. I'm going to put the 11 first, and then this one because the r is in the back anyway. So and then 3r. So 2 times 11 is 22, and 22 times 3 is 66. So that in fact does equal 66r. So it meets all our criteria. So then I can safely say, well, because it's minus and that's plus, then this is going to be 3r minus 11 squared. Box that in. Life's good. But what about this one? You say, okay, well, let's see. Let's look at the first term. Is that a perfect square? Well, x squared is, but 3 isn't. I'm like, oh, well, then it's prime. There's nothing we can do about it. Not so fast. Okay, so let's start talking about GCF, greatest common factor. One of the first thing, not one of, the first thing I want you to start looking for is the greatest common factor. Is there a number or a variable, or is there a term that you can pull out of all the terms in the polynomial? In this binomial, there is. 3 goes into both of these evenly. That means I can factor out of the 3. Think of it as like the reverse of the distributive property. So I can pull out a 3, which would leave me with x squared minus 100. You divide it out. Okay, 3 divided by 3 is 1. 300 divided by 3 is 100. Now I look at what's left inside the parentheses and I see, well, can I factor that now? And I can. Look, it's a difference of squares. That's x times x. That's 10 times 10, and there's a minus sign. So bring down the 3, include the 3. The GCF is part of your factors. Don't just pretend, oh, I pulled it out, now it's gone. It's there. You need it because you're writing an equivalent statement that looks different. So include that 3. So bring it down, and then x minus 10. So x plus 10, x minus 10. And then there's nothing else. So it breaks down to 3 factors, 2 binomials, and a constant. And you need all 3 of those to equal our original polynomial or binomial. Let's look at another one. GCF, is there one? What do you think? You might think, well, maybe 8, but 8 won't work for 28, so something else. 2 for sure, but 2 is too little. We can actually factor out a 4. Okay, so if you said 4, ding, 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 you got the right answer. So Now we factor out a 4. That's going to leave me with 2m squared plus 7. Oops, how did that happen? Magic. Okay. Plus 8m (7m) minus 30. Okay, so from here, we're going to factor out what's inside the parentheses, this trinomial. Okay, I'm going to bring down the 4 because I know that's going to be part of it. Well, I'll do that later, but I will do it in a minute. So let's take a look at this. Okay, so what times what gives me 2m squared? Well, it has to be 2m and m. We don't have much choice in that. Negative 30. So it's negative 30, so that tells me one term's positive, one is negative, and it needs to add to 7m squared. So we could do, let's say, 6 and 5. Let's make the 6 positive and the 5 negative. Okay, we'll try that out. We cross multiply. Well, that's going to give me negative 10m, and 6 times m, that's going to give me plus 6m. Well, that's going to give me negative 4m, and I need a positive 7, so that's not right. Okay, so we need to try something else. Let's try negative 6 here and positive 5 here. Okay, 2 times negative 6 is negative 12m, and 5 times m gives 5m, and we add that together, and that's going to give me negative 7m. Oh, so close. It needs to be positive, so let me change the sign. So that's going to be positive, that's going to be negative. Okay, so positive 12m, negative 5m, positive 7m. Okay, so these, not what I want to do. So this will be a factor, and this will be a factor, but don't forget to include your GCF. So it's going to be 4 times 2m minus 5 times m plus 6. And we box that in, and those are our factors. Okay, let's try another one. So let's see here. 7t squared minus 63t. Is there a GCF? Yes, definitely. We can pull out, in fact, a 7. Okay. But not only that, see how there's a t squared and a t? We can pull out a t. So that's going to leave me with, okay, so 7 divided by 7 is 1, and then when I have 2 t's, I pulled out 1, that just leaves me with 1. Minus, and then 7 divided by 63, or 63 divided by 7 is going to give me 9, and I had 1 t, I pulled out, I have no t's left. And I'm left with t minus 9. And there's nothing else I can do with it. GCF was enough. Okay? So it's completely factored with just the GCF. So sometimes that will happen. Okay, but always check for that GCF. Alright, so let's take a look at another one here. And our last one. So we're solving the equation. But here's the problem. When we're solving, it has to be set equal to 0. So the first thing we have to do is we have to set it equal to 0. So I'm going to subtract 17x from both sides. And I'm going to write it in order, descending order. So I start off with the largest exponent first, x squared, then minus 17, minus 17x minus 15, and then that equals 0. So now that I got it equal to 0, now we can start a whole factoring process. Okay, so what times what gives me 4x squared? 4x and x, or I'll just try 2x and 2x. I have a negative 15, so that tells me that the signs are going to be opposite. I could do, let's say, I'm going to shoot with, how about a negative 5 and a positive 3? Let's see what happens with that. So 2x times negative 5 is going to give me negative 10x, and then 2 times 3 gives me 6x. Well, that gives me negative 4x, but I needed negative 17, so that didn't work. That's pretty far off. Probably something bigger. I have an idea. How about negative 15 and positive 1? Okay, so let's see. Negative 2x times 15, that's going to be negative 30. Oh, that was a terrible idea. 30 is way too large. So that's not going to work. Okay, well, I'm just having a tough time with this.
Oh, you know what it probably is? It's probably not 2x and 2x. Okay, so it has, well, let's try 4x and x. Maybe we'll have more luck. Okay, negative 17 is pretty big. So I'm going to try 3 and 5 again. I'm going to put the negative 5 down here with the 4 and the 3 here. So let's try this. So negative 4x times 5, that's negative 20x, and 3 times x is 3x, and hey, look at that, negative 17x. Okay, so that was the trick. We had set up that part wrong. So you just got to play with it a little bit, but you can knock it out pretty quickly. You know, the guess and check, the guessing and checking that goes along. Okay, so now I know that my factors are 4x plus 3 and x minus 5 equals 0. Now we're solving, okay, so I got to set each one of these equal to 0. Either this one has to be 0 and this one has to be 0, because if either one of these equals 0, it sets the whole equation equal to 0. So this one I'm just going to add 5 to both sides, so x equals 5. Here I'm going to subtract 3, so 4x equals negative 3, and then I'll divide by 4 like so, and that's just going to leave me with x equals negative 3/4. So my two solutions, you set notation since I have 2 of them. That was a lousy one. That didn't help. Let's try that again. Alright, that's tolerable, I suppose. So negative 3/4 and positive 5 are two solutions. You can plug that into the original equation. It should equal out. That's how you can check it. Anyway, there you have it. Solving quadratics by factoring part